Hi guys, let's talk about waves. Okay, so we have three types of waves. We have transverse waves to start off with. Movement of particles are perpendicular to motion of wave. So basically the wave is moving in this direction towards, like, for example, to the right, and the particles are moving up and down like this. Okay, so that's perpendicular, right, at a 90-degree angle. So examples are a stretched rope. Like, if imagine you and your friend are both holding opposite ends of a rope, right, and you guys make it wiggle. That's a transverse wave. Trampolines are also going to move in transverse waves. Okay. Another really good example of this is the electromagnetic spectrum, which we will be talking about more in a second. Then we have longitudinal waves. Longitudinal waves are like a slinky, okay? And so imagine that you have a slinky stretched out across the table, right? And you're holding one end and your friend is holding the other end, and you basically like push it towards them, right? But you hold onto your end. There's going to be a wave that travels through the slinky, right? It's like a compression wave. And so these particles are moving parallel to the motion of the wave, right? The motion of the wave is going this way, and the particles are also moving this way, like compressed that way, right? And so that's a longitudinal wave, and this is going to be like sound waves are a good example. And then we have surface waves, okay? So this is like waves in the ocean, right? They're moving in a circular motion, and it's going to look like waves on the surface of the ocean. Okay, so those are transverse, longitudinal, and surface waves. So what are waves, right? They're disturbances that transfer energy from place to place. A transverse wave moves the medium at a right angle, right, or a 90-degree angle, or we could also say it's perpendicular. We have several examples of transverse waves, which are part of the electromagnetic spectrum, right? Visible light, radio waves, X-rays. I'm going to talk more about those in a second, okay? So properties of transverse waves. We have several different parts of a transverse wave. And so it's going to be a little easier for me to explain this to you when we label the wave. So let's go ahead and do that. So here we go. The amplitude of a transverse wave is how basically high it is from the origin. This dotted line right here is called the origin. And so how tall it is from the origin to the crest is the amplitude. Okay, think of like when you're talking about a speaker, right, has amps, that's amplitude. You can also measure amplitude to the trough, right? The trough is at the very bottom of the wave. So here we have the trough right here, okay? And so if I go from the origin down to the trough, that also will give me the amplitude, okay? The wavelength is from crest to crest, or I can do from trough to trough. That's going to be the wavelength also. The frequency, right? Frequency like means how often something happens, right? Like how frequently do you go to the movies? How often do you go to the movies, right? So that's frequency. Frequency is going to be from the origin through the crest, through the trough, back to the origin, okay? How often is that happening? That's the frequency of a wave. So if we go back here, right, we have amplitude is the distance from the rest, from the origin, right? The wavelength is the distance from the corresponding part, so like crest to crest or trough to trough. The frequency is the number of complete waves, and we measure this in hertz. That's the, you may have heard of hertz before, right? That's the unit that we use. And then we talked about crests are at the very top, right? And troughs are down at the bottom. Okay, so let's look at the electromagnetic spectrum, and I have a couple of pictures of this. And so here we have basically from a very low frequency, right? We have different signals that we have here, like radio signals, radio waves, TV, right? Radar, infrared. Here's visible light, right? This is where we can actually see light. And then as I get to basically a shorter frequency, then I'm going to be getting into X-rays and gamma rays over here. So this is going to be like radioactive elements. Here's another view of it, right? I have really long wavelengths over here, and then I have shorter and shorter wavelengths over here. And so I have radio, microwaves are going to have very long wavelengths, right? And then as I get more towards the right hand side over here, I'm going to have shorter wavelengths with visible light, ultraviolet, X-rays, and gamma rays. Okay, so that's basically a bunch of examples of different transverse waves. Okay, if you have any questions, let me know, and thanks for watching.